Welcome to Kinross at Kettle River and Buckhorn. For over 150 years, gold and silver mining has been an important part of the history and economic prosperity of northeastern Washington. Kinross is the area's largest private sector employer, providing jobs in Ferry and Okanogan counties for over 230 employees, including engineers, geologists, electricians, mechanics, miners, mill operators, and over 130 contractors. The Kettle River Mill has been in operation since 1989 and has processed gold ore from 7 different mines in the area. Kinross's active mine site is now 45 miles northwest of the mill at Buckhorn Mountain in Okanogan County. Kinross takes solid rock and turns it into gold bars. The story begins within the tunnels of the Buckhorn mine. Miners start by preparing a rock face called a heading. A 36-inch square grid is painted on the 15-foot by 15-foot rock face in preparation for drilling. Using a jumbo drill, a round of 12-foot deep holes are drilled horizontally into the rock. Next, the rock face is prepared for blasting. About 550 pounds of ammonium nitrate is pumped into the holes. Fuses are prepared, and the mine is evacuated and the headings are sealed off.
Fire in the hole, fire in the hole, fire in the hole.
After blasting, a fleet of loading equipment known as muckers enter the mine, and the blasted ore is loaded onto the trucks. Material is hauled to the surface and separated into stockpiles. Then the ore is loaded onto haul trucks and sent to the mill. With the heading now cleaned out, a boom bolter puts wire support into place to provide safety from falling rock. Friction bolts are drilled into the top and sides of the drift, holding both wire and rock in place. After bolting is completed, the rock face is ready to be painted again, and the mining cycle continues. Back up top, the trucks are loaded with ore and travel 45 miles to the mill. Each truck hauls about 35 tons of ore and contains about 10 ounces of gold. Upon arriving at the Kettle River Mill, the material is deposited at the ore storage area in preparation for entry into the mill. Separating the gold from the ore is a difficult and complicated process, as shown in this illustration. The process begins as front-end loaders feed the ore into the jaw crusher, where the rocks are crushed down to 4-inch pieces. The ore then travels into a cone crusher, which breaks it down into pieces smaller than 1 inch in diameter. Next, the ore travels by a conveyor belt into one of 2 rod mills. Heavy rods within the mills slam and roll against the ore, breaking it into smaller pieces. The ore then travels into a cyclone cluster, where it undergoes centrifugal motion and gravity separation. During this process, pieces of ore that are too large settle to the bottom and are sent to the ball mills, while the remaining ore proceeds to the next process. The ball mills are filled with metal balls, roughly the size of tennis balls. The balls, combined with the movement of the mill, help pulverize the ore into tiny pieces, approximately the size of beach sand. After the ore leaves the ball mill, it is sent back to the cyclone again, where it is now small enough to pass on to the flotation process. In the flotation tanks, small amounts of chemicals are added to the ore-water mixture. The chemicals make up a froth of bubbles that the ore can attach to. More than 60% of the gold-containing ore latches onto the bubbles and floats over the side, moving on to the leaching process. The ore that does not attach to the bubbles becomes flotation tailings, which are sent through a different leaching process. The ore that successfully passes flotation is sent into large concentrate leach tanks. Here, cyanide is safely added in a closed-loop system. Cyanide separates the gold from the rest of the ore and dissolves the gold into a solution. This process takes several hours and recovers about 90% of the gold. But how safe is working with cyanide?
When we're done doing the leaching, we can easily destroy the cyanide compound and make it harmless. And we do that by adding a sulfur dioxide gas and then agitating it, and it breaks apart the cyanide molecule. Once that's done, the cyanide's been decomposed. It's perfectly harmless.
Next, the gold travels into a carbon-in leach circuit. Here, the leached gold in solution attaches itself to small porous flakes of carbon, which act like a sponge. Once the carbon has been loaded, the gold and carbon must be separated through a process called pressurized elution. In the elution process, chemicals are added to the carbon-gold compound, and pressure is applied. The gold is eluted or stripped from the carbon. Next, the gold enters electrowinning cells, where an electrical current attracts the gold to metal plates, forming a sludge. The sludge is then removed from the plate, dried, and sent to the refinery, where it is melted in a furnace at 2100 degrees and poured into gold bars. Each bar weighs about 80 pounds, contains about 900 troy ounces of gold, and can be worth more than $1 million. The ore, when ground in the mills and mixed with water, is called slurry. Before the slurry is deposited into the tailings dam, it is treated in a large tank using the Inco cyanide destruction process, which destroys all free cyanide. All of the water used in the milling process goes through the Inco destruction process and is reused, making the Kettle River Mill a zero-discharge facility. Kinross is committed to environmental stewardship. All water from the Buckhorn mine is processed through a state-of-the-art water treatment facility. Over 144,000 gallons per day are treated and discharged in accordance with the state and federal permits. Kinross also monitors water quality at a vast number of locations throughout the area. Gold has multiple uses in our daily lives. It is an excellent conductor of heat and electricity and is extremely resistant to corrosion. We often think of gold as only being used in jewelry, but it also has many applications in electronics, aerospace, medical equipment, appliances, and automobiles. Gold forms the basis for world monetary funds, banking, and investment. Buckhorn mining operations use both the drift and fill and long-hole stoping methods. All the rock mined from the underground that is not sent to the mill is used to backfill underground mine workings. This backfill supports the mine workings and is an important part of the reclamation process, which also includes reshaping the topography, removing roads, and planting trees and foliage upon the closure of a mine. Besides creating jobs, Kinross invests in the community. In 2011, Kinross donated $228,000 to over 110 worthwhile causes in the local area. Based on current reserves, the Buckhorn mine is expected to last into 2015, but in order to keep the Kettle River Mill turning, more gold deposits must be found. Kinross is currently working on exploration projects to discover these gold deposits and maintain its vital economic role in the northeast region of Washington state.
The economic engine that this brings certainly to a community this size in the times of today, where the economy is challenged anyway, it's absolutely, it'd be earth-shattering. It makes a huge difference. So we're certainly trying to keep operations going in this part just as long as we possibly can, because we want to live here too.
Kinross at Kettle River and Buckhorn, committed to responsible mining, committed to a strong future.